Okay, so today what we're doing is we're finding the volume of the figure formed by region bounded by y equals x, which is going to be this right here. Y equals x. Y equals 3, which is a horizontal line right here, and x equals 0, which is going to be the y-axis. And we're going to rotate or revolve it around the x-axis as such. Okay? Now, one thing we're going to notice is that this region right here is not all touching the axis that we're revolving about, correct? Now, remember, when we looked at ones from like this one right here, and we're rotating this region about the x-axis. This entire region was touching that x-axis. Therefore, when we looked at this cross-section, it was a solid circle, correct? That was at this bit. Now this one, you can see that the entire region is not going to be touching. And so if I was going to, and so basically what it's going to look like is going to be this, basically like a cylinder with a cone cut out of it. But what's going to happen, well, actually, let me just go ahead and take a sketch of it right here. So we've got 3. Here's this. Here's y equals x. Here's y equals 3, and x equals 0. So it's going to be this region right here. Now I'm going to make a mirror image over the axis that we're revolving about, the x-axis. And you can see that we have a cylinder with a cone cut out of it. You all see that? Cylinder with a cone bore out of it. Okay? Now, if I took a cross-section and looked at it, what would I see? What would it look like? If I took a cross-section anywhere on here and looked at it, what's it going to look like? It's going to look like a circle with a hole in it, correct? It's going to look like a circle with a hole in it. Thus, this is called the washer method. Anytime where the region that's being revolved about an axis, if it doesn't completely touch the axis it's revolving about, there's going to end up being a hole in the middle, and we're going to end up using the washer method. Then we use the washer method. Now, if I was going to find the area of this, would you all agree that it would be the area of this entire circle minus the area of that hole, correct? So that's going to be the formula that we're going to be using. The formula we're going to be using is going to be pi big R, which is the radius of the big circle, basically, minus pi r squared with the little radius. And we're going to be integrating from A to B. Okay, so it's going to be the volume of that figure is going to be pi big R squared minus pi little r squared. We're just finding the volume of this whole thing right here and subtracting what the volume of what we're boring out. Okay. So looking back at our one we're just talking about, once again, little sketch. Y equals x. Y equals 3, and x equals 0. It's going to be this region here, revolving about the x-axis. So make a little mirror image down here. Look like this. We set a cylinder with a cone bore out of it. Okay. So we're going to find the volume of this now. We have to find out where it is going to be from what to what in regards to the x-axis, because we're revolving about the x-axis. So we can see that it goes from 0, and then how far are we going up to here? What's that going to be with regards to the x-axis? From 3, from 0 to 3. Now, if you're getting confused on where exactly that's going to be, you can just set, it's where these two functions intersect, yes? So you just set those equal to each other. Y equals 3, y equals x. You just set the values of y equal to each other, x equals 3. That shows you that's where it's going to end up going to. And it's going to be pi big R squared minus pi little r squared dx, because we're revolving about the x-axis. Now looking at this, what is the big radius going to be? It's never changing anywhere on this. Y'all see that? The radius never changes anywhere you're looking at. If I took a cross section, it's always every washer is going to be exactly the same amount wide, correct? It's never going to change that way. So what is the radius going to be here? What's it defined by? For all these cross sections, for all these circles, the radius is always going to be 3, correct? The big outside radius is going to be 3. So it's going to be pi times 3 squared minus pi times the little radius squared. Now the little radius is going to be what you're boring out, basically. Okay? It changes as you're going further down, correct? It's going to be changing that. When it's boring out, the radius is changing. So what's defining that? If it's changing, that means it's going to be defined by a variable, correct? Okay, so it's defined by a variable. What's it defined by? What's this right here defined by? Y equals x. Perfect. So the radius is always going to be x. The little r is always going to be x. Okay, so it's the big radius minus the small radius. The big radius of this is not changing. It's constant. It's defined by y equals 3 minus the little radius, and the little radius is changing. It's defined by y equals x. Now you'll see that you have pi here and here. What you do is factor that out. And you can always do that with the your the integrals on these always. Once you start working with these, you can always factor that pi out. I'm going to start do that at the beginning of every one. I just wanted to remind y'all that it's area of the square minus area of the square of circle, my bad. Area of the circle minus area of the circle. So what's left over is going to be 9 minus x squared. That's going to be my integral. And I take the antiderivative. Can you see this, Julianne? Why didn't you say anything? You don't fries it up. Alright. So I'm going to take the antiderivative. It's going to be 9x minus 1/3 x cubed. That's your antiderivative. You're going to substitute in 3 minus 0. Anytime you substitute in 0, if it's not a trig integral, it's always going to be 0. You're always adding an exponential power of x. So it's going to be pi times 27 minus 3 cubed is 27. 1/3 of that is 9. So it ends up being 18 pi units cubed. Can you see it now? Good. Right, anybody questions on that? All right, let's get another one. Okay. So this is right here. Sketch a figure, find the volume when you give an area rotated about the x-axis. Like I said, over the next couple of days, I'm going to post stones that are rotated about the y-axis. Which is basically something the same mechanics are the same, we just think about it a little different. Graph. So y equals x squared, 0, 0, 1, 1, 2, 4. This is parent function behavior, y equals x squared. Y, or x equals 0, which is the x-axis, or y-axis, my bad. And y equals 4. So we're just, and it should actually say an x is greater than 0. So that way we're just looking at this region over here. Now we're revolving that around the x-axis. And I'm going to make a mirror image down here. So what I have is a cylinder with basically like a tornado pour out of it, right? Y'all see that? It's like a cylinder with a tornado and little thing pour out of it. So how far am I going with respect to the x-axis? From 0 up to, how far am I going? What you can always do, once again, is set your functions y equals x squared and y equals 4. Set x squared equal to 4. The two y values are equal to. That's going to show you the x values for which they intersect. Now x would be equal plus or minus 2. You might say, well, am I supposed to be going from -2? That would be the case if I went this way, correct? -2 would be intersecting as well, but I'm just going to get a positive 2. So we're going from 0 to 2. I'm going to put pi out front. It's big R squared minus little r squared. So what's the big radius going to be? What's the big radius going to be? Does it change? Nope, it's constant. So it's going to be what? 4. Excellent. Go from 0 to 2. That's going to be 4 squared minus, and the little radius is going to be what we're boring out. So it's changing, yes? Depending on what we're talking to. It is defined by what? X squared. Perfect. X squared. So it's going to be from 0 to 2 of 16 minus x to the 5th. See what I'm working with? So it's going to be pi times 16x minus 1/5 x to the 5th. I think y'all are probably accustomed to seeing this enough times. It's in the end of the explained. Correct? So pi 16 times 2 minus 1/5. 2 to the 5th minus 0, get that. So I get 32 minus 2 to the 5th is 35. 32, my bad. So 32 over 5. So it's going to be 32 pi minus, I'm sorry, let me back up on that. Let me go ahead and get a comment on it first. 32 times 5 is 160. 5 minus 32 over 5. So you end up with 128 pi over 5. Okay. Any questions on that? Do you have any questions, Andrew? All right, now this one, y equals x squared, y equals x. Y equals x squared, I'm going to have 0, 0, and 1, 1. 2, 4, maybe I'll put something like this. And y equals x, it'd be 0, 0, and 1, 1 as well. Okay? So therefore, it's going to be this little region here. Now, it might not be so obvious which one's above the other one, which one's a big R, which one's a little r, correct? Now, we can see that where they intersect, we just set the y values equal to each other. X squared equals x. Bring x over here. Factor x out. And x equals 0 and 1, which is the case, 0 to 1. So that means our integrals will go from 0 to 1. Now, which one's big R, which one's little r? If it's confusing to see, what you can do is pick a value in between 0 and 1. Say 1/2. And just plug those in. So y equals x. So if x equals 1/2, obviously it's going to be 1/2 for the y equals x value for this one. And for x squared, what's 1/2 squared? 1/4, right? So therefore you can see that this one is going to be above this one for our region. Does that make sense? The y equals x is going to be the outer, y equals x squared is going to be the inner. So if I made a sketch of this, it basically looks like this. So it's basically going to be a cone with a tornado, basically a tornado bore out of the cone. Okay? So big R is going to be defined by this one. That's the one that's on the outside, because they're both going to be variables now. So big R is going to be defined with the radius of x. And the little r is going to be the inside one, which is defined by x squared. Does everyone follow that? Does that make sense? And we'll see how you determine which one's down the outer, which one's on the inner. Complete silence is a resounding yes. This is x squared minus x to the 4th. Antiderivative is going to be 1/3 x cubed minus 1/5 x to the 5th. From 0 to 1. It's going to be 1/3 times 1 cubed minus 1/5 times 1 to the 5th minus 0. Which ends up being 1/3 minus 1/5. The common denominator 15. And we get 5 over 15 minus 3 over 15. And we get 2 pi over 15. Any questions on that? I'm going to stop the recording on this.